Okay, I want this to be a really quick little video that just summarizes how you deal with calculating the weighted average with precipitation data. So let's assume we have some area here and we have 4 measurements of precipitation at spot locations, 1, 2, 3, and 4, and each of those precipitation measurements are supposed to be applied over an area. So for example, the first spot measurement of precipitation is supposed to be applied over this area in blue in here, okay, etc. And the same thing's true with the others as well. So the formula we're going to use is as follows. The weighted average, so the average, weighted average, weighted, will equal the weight of area 1 times P1 plus the weight of area 2 times P2 plus weight 3 P3 plus weight 4 P4, where the weights have the following characteristics. So the weights of 1 is equal to the area of 1 divided by the total area, which will equal the area of 1 divided by the area of 1 plus the area of 2 plus the area of 3 plus the area of 4, etc. Right? So the weight of 2 will equal the area of 2 divided by the total area. And one important condition here that you can always test is that if you've done this correctly, the sum of all the weights, and I'll use this little summation sign, the sum of all the weights should equal 1.0. In other words, for this example, the weight 1 plus weight 2 plus weight 3 plus weight 4, if we've done this correctly, should sum to 1.0. So this is the way you would calculate the weighted average of precipitation data weighted by area. So let's go over a specific example. So here we have the exact same geometry as what I showed you before, but now I've assigned precipitation data in orange letters and areas in pink letters. So for example, the first area, that first precipitation measurement, P1, was 35, let's call it millimeters per month, and the area of that region is 80, let's call it kilometers squared. So what I need to do is set up a table summarizing my precipitation data and areas for each of the stations. So here I've entered all my data, the data for the 4 stations. And the first thing I need to do is calculate the total area by summing up the areas from each of the 4 regions. And if I sum these all up, I get a total area of 205 kilometers squared. I won't put the units on here, but these are all in kilometers squared, just so we're sure. Now to calculate the weights, what I'm going to do for each of these is take the area divided by the total. So the weight for the first one will be 80 divided by 205. 80 divided by 205, and that is equal to 0.390 to 3 significant figures here. And if I do the same thing for the rest of the regions, I get the following. I get the following 4 numbers. And importantly at this stage, one way to check that I've done this right is if I add up all the numbers in blue, the weights, I should come up with, and I do come up with, a weight of total of 1.0. So I have done this correctly. So those are my weights. The next step is to multiply the weight times the precipitation. The weight in blue times the precipitation in orange. So for the first one, I'd have 0.390 times, so 0.390 times 35 is equal to 13.7. And the units here are going to be whatever precipitation was. If precipitation was in millimeters, I think I said millimeters per month, right? Then this will be in millimeters per month as well. And I do the same thing for the other 3 regions. I multiply the weight times the precipitation, and I end up with the following values. And now all I have to do is add up these 4 numbers in green, the products of the weight and the precipitation. And if I do that, I get 27.9 millimeters per month. And that is my final weighted average. And I'll highlight that in green like that. So that's how I calculate the weighted average for precipitation data when I'm weighting it by the area over which each spot value of precipitation applies.